Alright guys, here we are. It's our first podcast together. That's so exciting. Thank you guys so much for the outpouring support and words of encouragement that you guys have been sending me and support on YouTube. I've really appreciated it. This is our channel, Your ABA Help, and I am Sarah. I'm a BCBA, and today we are going to be talking about some of the task lists. So the way I'm going to break up these podcasts for you guys, every Sunday I'm going to be uploading one, and it's going to be over a few parts of the task list. My goal is to make this video around 30 minutes, so that way it's nice and digestible and not too much, you know. I wanted to be able to keep your attention. So about 30 minutes. Today we're going to do A-1 and A-2, and then we're going to talk about what those are. So A-1 is identify the goals of behavior analysis as a science. That's going to be that description, prediction, and control, guys. And then A-2 is explain the philosophical assumptions underlying the science of behavior analysis. That's going to be those 6 attitudes of science. So we're going to cover those 2 today, and then next week we'll continue on that task list, and we're just going to work our way through it together, and it's going to be super fun. I've got a lot of little fun projects in the works for you guys. I'm just so excited. So again, thank you so much. Let's go ahead and get into this podcast. I'm going to give you guys the definitions of each of these as I go through. I'm going to break it down for you, give you some examples. We're going to talk about it and apply it, okay? I know there's some like definition nerds out there, and you know, you do you. I'm not going to tear you down, but I do want to say, guys, you do not have to memorize these definitions for word, okay? You just need to be able to tell the difference between the definitions and each other and who belongs to what, but you don't need to be able to recite these definitions, okay? So don't try to memorize them unless that's your jam, then go for it. So we've got our description, prediction, and control, the 3 characteristics of science. So our definition of description, guys, is descriptive knowledge consists of a collection of facts about the observed events that can be quantified, classified, and examined for possible relations with other known facts, and is an important activity for scientific discipline. What the heck does that mean? So all this one is talking about is we want to know the data on what we can see. We want data, we want numbers, we want facts in science, right? So let me give you an example. So if we're in clinic working with children, we are tracking their behaviors, we'll see them flop 4 times. Or maybe we're stating a fact like the lights were on, lights were off. Clear descriptions. Maybe I was measuring how many chips I ate one night, so I'm trying to eat less chips, and I noticed I ate 4 cups of chips. That's it for description. That's all we are talking about, just the data. Our next step there is going to be prediction. So prediction, I'm going to give you the definition of. Prediction, it is the presence of one event and another event occurs with some specified probability. So again, also means is correlation. So we are making a hypothesis. We are looking at A equals B. So when we're looking at like ABC data, this is going to be that antecedent and that behavior. So we suspect when this happens, that's going to happen, okay? In our example of like little Johnny flopping, we are talking about what happened before that. So maybe, it could be way before that. Maybe every morning Johnny comes in late, he flops 4 times, or every time the lights turn on, little Johnny flops. So we're looking at the hypothesis. So we're thinking in our heads, we're like, okay, what's going on with this behavior? And it can also be in our everyday life, right? Every time I watch true crime, I eat 4 cups of chips. Hypothesis, right? And then next, we move to control. So this is where we start to get that science experimental analysis, okay? Control is where we are. Control is the evidence of the kinds of control that can be derived from scientific findings and the physical and biological science surrounds us in everyday technologies. Control, that is going to be when we are testing our theories, and this is going to be that science part. So in my example of me eating 4 chips every time I watch true crime, this one is going to be where we take a week and every other night I watch true crime, and the other nights I watch my husband's show, and we take data on how many chips I'm eating. So we use description to measure my behavior, prediction to make our hypothesis, and then control to test it. So if I am watching true crime, I eat 4 cups of chips. Well, what about on the nights that I'm watching my husband's show? Am I still eating 4 cups of chips? That's where we're testing those hypotheses, okay? And, in clinic, so we were testing, okay, so little Johnny walks into this room and he flops. What do we think is going on? So let's say we notice that every time we turn on the light, little Johnny hits the floor and he flops and he seems like he's in distress. There could be a few things going on. Maybe it's the clown picture. Maybe it's his teacher. Maybe it's the lights coming on. We've got to test it. So, over the next couple of weeks, we are manipulating those variables and we're testing it and seeing if our hypothesis is correct. Cool. I hope that sounds good for you guys. Some other terms in there you're going to want to know is functional relation. So, do our variables have a functional relationship? This is what we're doing for control. So we are trying to determine when we manipulate one variable, does it impact the other variable as we're expecting or not? I'm going to go and give you the definition of functional relation. I'm going to give you the definition of a functional relation. Exists when a well-controlled experiment demonstrates that a specific change in one event, the dependent variable, is reliably produced by specific manipulations of another event, the independent variable, and that the change in the dependent variable is unlikely to be the result of other extraneous factors, confounding variables. So all that fancy stuff is just when we manipulate those variables, are we getting the results that we are expecting, we should be getting, and it's not other things. There's a clear relationship. We're going to talk about the 6 attitudes of science. I kind of talk about how we do this and make sure it's all scientific and it'll kind of all tie together. Another thing to know about description, prediction, and control is the more you move up that hierarchy. So description is the least specific, prediction is being more specific, control is going to be kind of that top most specific thing. So keep that in mind. We are going to go ahead and spend the bulk of our time on these 6 attitudes of science, guys. So this one is just memorization. It's just fluency, repetition. I definitely recommend saying these out loud to yourself. I found that really helpful to just kind of get it out of my head and making sure I can regurgitate it and say it. And it's really sinking in my brain if I'm doing that. So I found that super helpful. So I definitely recommend if you are in your car or if you have no shame in Target, go ahead and repeat these to yourself, talk out loud. At the end, we will go through and kind of do a little quiz. I'll have you fill in the blanks to make sure you're really listening and retaining this. So stick around for that. But let's go ahead and talk about these 6 attitudes. You ready? The most common acronym, it's the one that I personally use, so I'm going to use it for today's podcast here, is DEER PP. So DEER PP. Our first one that we've got is D, which is determinism. I'm going to give you the definition. I'm going to give you the shortened version, the keywords, things like that. Way to remember it, an example, okay? So determinism. So determinism is when all scientists presume that the universe is a lawful and orderly place in which all phenomena occur as a result of other events. All that means is everything is happening for a reason. So nothing's happening out of the blue. Determinism is kind of anti-miracles, think about it that way. Determinism is going to be explaining why you won the lottery. It wasn't because you went to church 4 Sundays in a row. It was because you bought a scratch-off ticket and you scratched it and you won. Period. It kind of takes all the magic out of things. It's very strict. It's very much there's a reason for everything, cause and effect, all that fun stuff. A way that I remember determinism is determined. You're determined to figure out the right answer. Period. Cool, you got it. All right, up next is empiricism. So this one is facts, data. Think about how we use data and facts in very clear numbers and description like we just talked about. That's going to be empiricism as well, guys. Same thing, so I'm going to give you that definition. Are you ready? So empiricism is the practice of objective observation and measurement of the phenomena of interest. Objective observation, that's all you need to know. Those numbers, very clear, data. All right, in a way that I like to remember this, I learned from Study Notes ABA actually, and it's the best one. I can't think of a better one, so I'm going to go ahead and use it. So empiricism starts with an E-M-P, and the word emperor starts with E-M-P. So an emperor is going to be very demanding. He's going to want the facts. He's going to want the answers now because his village is on fire. He needs the answers. Empiricism, guys. Facts, clear data. So an example of this kind of in clinic, that's going to be those 6 flops. That's going to be those 5 minutes of crying, that he was wearing a blue shirt that day. Facts. Up next, we've got experimentation. So experimentation is exactly what it sounds like. Don't overthink this one. I'm going to go ahead and give you the definition. So experimentation is to investigate the possible existence of a functional relation, an experiment, or a better series of experiments must be performed in which the factors suspected of having causal status are systematically controlled and manipulated, while the effects on the event under study are carefully observed. Whew, that's a big one. So that's just a fancy way of saying science. So we're experimenting, we're manipulating variables, we're testing things, we're trying things out. That's all it is. So experimentation. If I do this, will that happen? Think about this as kind of a big part of that prediction, right? Prediction and control. So we're moving into building hypothesis, testing it. We're looking at little Johnny flopping when the light turns on. We're going to be testing it and we're going to be experimenting, making sure we're right. For experimentation, we had just talked about a functional relation, right? We want to see the relationship between variables. And in experimentation, there's also a functional analysis. So this is where Skinner took it a step further and started to use it in ABA. This is what makes ABA what it is we're analyzing those environmental variables and manipulating them, right, guys? Okay, so we are about halfway through these. I hope you're hanging on tight. You're doing great. We're going to learn these, and we're going to talk about them at the end. We're going to review them. It's going to be awesome. So up next of our Dear PP is replication. This one is exactly like it sounds, to replicate. So I'm going to give you this definition. So replication is repeating of experiments as well as repeating independent variable conditions within experiments. So we've done our experimentation. Next, as you know, scientist 1, I've done my experiment. And I've tested, and I've created my paper, and I've published it. I said, look at my findings. These are amazing. Replication is taking that next step, and I'm going to be scientist number 2, 3, 4. They're going to replicate my findings and make sure that my experiment is correct. So a big thing about replication is this is the one that finds human errors. So it finds out that actually, you know what, that work you did in that study was wrong, or you missed this variable, or your data is a little inaccurate here, things like that. Replication is going to find that human error because we're repeating it, we're proving it, and we're seeing that functional analysis over time is continuing to occur. We have our first P of Dear PP, parsimony. So parsimony is an attitude of science. Parsimony requires that all simple logical explanations for the phenomena under investigation be ruled out, experimentally or conceptually, before more complex or abstract explanations are considered. Parsimony. So this one, all it is the simplest theory is being ruled out first. We aren't going to overthink it. We're not going to go to the craziest thing first. We're not going to put in the most complex, behavior plan. Instead, we're going to do the simplest options first. We're going to consider what's simplest. Let me give you some examples here. For parsimony and considering those simplest things, I really like the example of new parents when they get their kids sleep through the night for the first time, and they're just like, okay, my baby is wearing 2 layers, they ate this many ounces, the room was this temperature, the humidity of the room was this, the sun was here, the moon was this phase. You really overthink it because you're like, I really want that to happen again. Whereas the simple solution was probably your baby was just tired and they're getting older, so they're going to sleep through the night more, and this was just the first time. Simple as that, right? Magical as could be, that's science, right? So take the simplest explanation. So in clinic or in home, little Johnny's walking through that door and he hits the floor, he's flopping, he's covering his ears. My first instinct shouldn't be like, okay, it's probably because that new multivitamin that he had, or no, it was those antibiotics that he had 3 weeks ago. I bet it's that. It should be the simplest thing. It's those lights, or it's that clown picture, or it's a teacher he doesn't like, things like that. Considering what's right in front of you. A good way I like to remember parsimony is parsimple-mony, parsimple. Parsimple. It's simple explanation. Cool, you got it. All right, up next is philosophical doubt. All right, here's a definition for you. Philosophical doubt requires the scientist to continually question the truthfulness of what is regarded as fact. Scratch that. All right, the definition of philosophical doubt requires that the scientist continually questions the truthfulness of what is regarded as fact. So this one is healthy skepticism. It's always questioning things. It's, asking others, are we sure about that? Even though we all buy into it. It's continuing to question yourself, questioning the science, questioning all things around you. You get it. A way I like to remember this one is I doubt that, Phil. Philosophical doubt. I switched the two words, doubt that, Phil. So I'm being doubtful. Or you could say doubtfully. Philosophic doubtfully. Some people like that one too. So whatever works for you. But this one, doubt. Just remember that word. We're being doubtful that is just always correct, and that's the answer forever, right? An example for philosophical doubt is me continuing to question if my protocols are working, continuing to question, the science. So the other day I was thinking, why do most BCBAs do 80% for 3 days for their mastery criteria? Is that best? We're going to look into the data. We're going to test it. We're always going to be questioning, even though that's the gold standard. Why? I don't know. Let me look into it and figure it out. And it's always okay to be skeptical and questioning yourself and others. All right, the next term that we're going to cover is called selectionism. Selectionism is that all life forms naturally and continually evolve through their learning history and evolutionary development. This happens at the individual level and also on a species level. So when we're talking about ABA, we're talking about learning and the environment impacting us and how that works. So when we're teaching these new skills, we've got to look at what is being taught to our clients and what we know is reflex or instinct versus what we can learn in this lifetime. Quick little disclaimer, if I'm messing up how to say these, I am so sorry guys. I did my best, so bear with me. First we have phylogeny, which is the natural evolution of a species, which includes the inheritance of survival characteristics passed down from one generation to the next. So when we're talking about this one, we're talking about instincts, survival of the fittest, all that fun stuff. It really shows us not everything is learned in the sense of we need somebody to teach us. We have our instincts and survival is what phylogeny is talking about. And for ontogeny, this is the one where you're having the environmental changes on one individual over a lifetime impacting their skills and their learning history. So this could be where you're raised, how you're raised, different things that happen to you in your environment. It could be major things, little things, like what kind of parents you have. All that fun stuff falls under the ontogeny category. There is a saying that you can use that I use to kind of help me remember, just saying that ontogeny creates phylogeny. Those little things that you're learning now over time creates generations of learning history. That is the 6 attitudes of science, guys. So let's do a quick little recap here. So we've got Dear PP, determinism, empiricism, experimentation, replication, parsimony, philosophical doubt. And then our 3 characteristics of science are description, prediction, and control. So that's A-1 and A-2 of our task list. Up next, we're going to go into some questions. I'm going to ask you guys to kind of fill in the blanks here to make sure you're retaining that info. Like I said, practicing these out loud to yourself. I'm going to ask you the question. You're going to fill in that blank for me, and I'll give you the answer afterward just so you can make sure you're right. Cool. You got it. You ready? What are the 3 attitudes of science? Cool. Description, prediction, control. Which one is the highest standards of the attitudes of science? Which one is the most specific? Control. You got it. Okay. So we've got descriptions on the bottom, control, predictions right up top. That is the best All right, and then what are the words that go in the acronym Dear PP? It is determinism, empiricism, experimentation, replication, parsimony, philosophical doubt. If you didn't get that, just keep practicing saying it over and over and over, and you will get it. All right, so which one of the 6 attitudes of science is concerned about repeating previous experiments and getting rid of that human error and proving that, that experiment's data is correct? Replication. All right. All right, up next, which one is the simplest? So we want the simplest answer. We're not going to overcomplicate it. Parsimony. Parsimple. Moni. If it works for you, hey, I'm not here to judge. Okay. Up next, we have the one that talks about how nothing happens out of the blue. There's a reason. There's a cause and effect for everything. Determinism. All right. I hope you're feeling comfortable with these guys. I hope you're feeling confident. If not, listen back again. We're going to keep practicing. But I want to keep these podcasts short and sweet because it's a lot of information. I don't know if you've looked at Cooper recently. It's like 800 pages, guys. So yeah, I'm going to go ahead and end this podcast here. And I will see you guys next Sunday. And I'm going to be back with A3, A4, and A5, talking about some history, Skinner and Watson. It's going to be a really good time, guys. I'm very excited to look up their little portraits and put them in our YouTube video. If you want to watch the visual part, go for it. It's going to be a fun time wherever you find this podcast. But I'm going to go ahead and close this out and just say thank you guys again so much. I hope you enjoyed this. Please give me all your feedback on what you like, what you don't like, what you need more of, all that. I'm so excited for you guys to listen to this and start benefiting from it, and I can't wait to hear about it. Have a great rest of your day. Bye. Remember, you got this.